Welcome students to a short presentation that highlights parts of Chapter 4, which is titled Carbohydrates. Now, could you imagine a world without sugar as we know it? Cakes, sodas, ketchup, bread, sauces, jams and jellies, ice cream, candy, and the list goes on and on. And you can see all these pictures here on the screen, and that's what most of us think of when we think of the word sugar, which is often why carbohydrates are villainized in our culture. However, carbohydrates are so much more than just the sweet, delicious things pictured on this slide. Carbs are naturally found in fruits, vegetables, whole grains, and beans, all of which are foods that can be part of a healthy, nutritious diet. Now, in the following slides, we will take a closer look at some interesting information related to carbohydrates. Now, I feel certain that most of you are somewhat familiar with carbohydrates and their structures. Maybe you learned about that in high school, but let's quickly review. Carbs are molecules made up of carbon, hydrogen, and oxygen, which is why you may see them called by the acronym CHO. And these are arranged to form one or more sugar units, like glucose, as seen on this slide, which is just one sugar unit, and sucrose, which is made of two sugar units, glucose and fructose joined with a glycosidic bond. Carbohydrates are found in many plant foods such as fruits, grains, barley and brown rice, and also in milk and milk products like yogurt. Carbohydrates are a key source of fuel for our bodies, especially our muscles, red blood cells, and brain. And as you know already, because we've talked about this in the past few modules, they provide 4 kilocalories of energy per gram. Now, one of the other animations I provide in Canvas breaks carbohydrates down and discusses the differences between simple and complex carbohydrates. So be sure to take a look at that particular animation. Now, something I wanted to highlight in this presentation is some terminology you may see when you are talking about or listening to someone discuss sweeteners. This slide focuses on nutritive sweeteners, and the next slide will focus on alternative or non-nutritive sweeteners. So honey, fruit, and maple syrup are examples of nutritive sweeteners, so it makes sense that these would provide calories. These types of sugars are either consumed by themselves, such as fruit, or added to foods to sweeten them. Food manufacturers add sugars to many foods to either increase the sweetness or as a preservative because they bind water in foods, lowering the water activity. Now, since microorganisms need available water for growth, when you reduce the available water, it keeps bacteria and molds from increasing in numbers, thereby preserving the food. If you check your food labels while shopping and you see that the first ingredient or one of the first ingredients is sugar, then the sugar content in that food is likely quite high. I would like you to also view, if you have time, the video on high fructose corn syrup in Canvas because that has been a hot topic for a number of years. Conversely, alternative sweeteners are those that don't provide any energy. So if they provide nearly zero calories. These types of sweeteners are often chosen by those trying to reduce their intake from sugar. Sugar alcohols like xylitol, mannitol, sorbitol, and erythritol are also alternative sweeteners found in chewing gums, sugar-free breath mints, and candies, and even some beverages. Added sugars must be on the current nutrition label. However, sugar alcohols are not considered added sugar since they do not actually add calories. The other group of alternative sweeteners are the non-nutritive sweeteners such as stevia, Splenda, Equal, or Sweet and Low, which are very sweet in comparison to the same amount of regular sugar. They are derived from plants, herbs, or even sugar itself. Now, table 4.5 in our textbook shows the comparison of the sweetness of several non-nutritive sweeteners compared to regular table sugar. I provided additional information about the stevia making process in the chapter materials in Module 4 on the Canvas site. So if you get a chance, take a look at that too. Now, shifting gears away from carbohydrates that actually sweeten foods, I wanted to touch on complex carbohydrates, especially whole grains versus refined grains. Now, whole grains are those that contain the entire kernel, including the endosperm, bran, and germ. Some examples of these are quinoa, brown rice, and oats. According to the 2020-2025 Dietary Guidelines for Americans, half of our daily grain intake should be from whole grains. And unfortunately, most of us do not take in the recommendation of 3 or more servings of whole grains per day. This is for several reasons, usually including taste and texture preferences. Because, for instance, whole grain bread, which contains the ground bran of the wheat grain, contributes ferulic acid, giving it a different taste than white bread, which doesn't contain the acid. Many people don't like the taste of wheat bread because of this, and often sugars are added to make the bread taste better. Now, the cost of whole grain bread is usually a little bit higher than white bread, which often causes white bread to win out over wheat. So, why is whole grain more expensive? Generally speaking, the ingredients in white bread can be bought cheaply in bulk, like white flour and sugar. And since white flour does not spoil as quickly, it can be stored in huge amounts and not purchased as often by companies who produce the bread. If the whole grain bread is organic, that can add even more cost due to stricter harvest and manufacturing methods. The marketing of whole grain food products can be a bit deceptive, especially when you see terms like stone ground wheat or cracked wheat or made with wheat flour. These terms really don't mean a thing other than the bread may be made with white flour and have a few seeds sprinkled on the top of it. The Whole Grains Council has tried to simplify the act of identifying whole grains by providing a stamp that verifies a product as being made with whole grains. So let's take a look at that. Now, in 2003, a group was formed to help consumers identify whole grain foods more easily. The Whole Grains Council is a nonprofit consumer advisory group whose mission is to increase consumption of whole grains for better health. The council has developed 3 different stamps that may be used by food manufacturers for their packaging to indicate how much of a product contains whole grains. This is a voluntary program, and in order to obtain the right to use the stamp, the manufacturer must be a member of the Whole Grains Council. Then their product's whole grain content must be verified by the council. It then becomes a legal binding contract between the council and the food company that the company will manufacture food products with the designated amounts of whole grains in them. Even with the stamp on the food product, you still have to be careful. Check the ingredient labels, as many whole grain products still contain lots of added sugar, fats, and sodium. So we've touched on whole grains. So what is a refined grain? You've probably heard that before. The term refined grain is used to describe grains that are not whole because they are missing one or more of their 3 main parts: the bran, the germ, or endosperm. The bran is the outer layer of the grain kernel and contains antioxidants, B vitamins, and fiber. The germ, which is the plant embryo, contains B vitamins, protein, minerals, and healthy fats. So when these are removed during refinement, many nutrients are unfortunately lost. Now, when the milling technology developed in the late 1800s to remove the bran and germ from grains, interestingly enough, nutrition problems quickly arose, such as pellagra and beriberi. We learned earlier that pellagra is caused by a deficiency of niacin. Beriberi is a deficiency of thiamine or vitamin B1, and both of these vitamins can be found in whole grain foods. It wasn't until the 1930s and 40s that the U.S. began to recommend grain products be enriched or replenished with the vitamins and minerals lost during refinement. Even though enrichment does increase the nutritional value of many foods, often the main source of refined enriched carbohydrates are white flour, white bread, white rice, pasta, and breakfast cereals with lots of added sugars, fats, and sodium. Now, when it comes to carbohydrates, what does a typical American consume per day? On average, Americans consume about 47% of their kilocalories from carbohydrates. The Dietary Guidelines for Americans recommends that 45 to 65% of your total calories come from carbohydrates. So, for example, if you eat about 2,000 calories per day, Between 900 and 1300 calories should be derived from carbohydrates, preferably from ones that are mostly unrefined. This is about 225 to 325 grams of carbohydrates per day. And although carbs get a bad rap, they're vital to your health, especially if you focus on carbs from fiber rich sources like fruits and vegetables, whole grains, low fat dairy products, and legumes. Added sugar should be minimized or avoided completely since there is no health advantage associated with their consumption. Now, in 2017, Americans consumed about 22 teaspoons of added sugars per day. Remember, these are not the sugars found naturally in foods like bananas or sweet potatoes, but the ones added for flavor, texture, or preservation purposes. The dietary guidelines recommend that added sugars be kept at fewer than 10% of your total calories per day. Major sources of added sugars in the American diet are regular soft drinks and energy drinks. For instance, one of the popular energy drinks on the market right now contains 54 grams of sugar in one 16-ounce can. That's more than 13 teaspoons, which is almost hard to believe, especially if you see 13 teaspoons measured out. So the bottom line is you really need to check your food labels. The FDA has recently attempted to make this easier, but amending the nutrition facts panel to show added sugars. Scientific data shows that it's difficult to meet nutrient needs while staying within calorie limits if you consume more than 10% of your total daily calories from added sugar. The old label, which you see on the left in the graphic on the screen, did not show added sugars, and the new one does. Showing this helps us determine what percentage of our sugars are added rather than lumping them all together in just a total sugar or carbohydrate category. Now, there are lots of other topics in this chapter, but this concludes what I am going to talk about today. However, I encourage you to watch the other animations presented in Canvas in the module, as these explain other aspects of carbohydrates. I do want you to pay particular close attention to the information on maintaining normal blood glucose levels, diabetes, including the various types, and other syndromes and conditions caused by too much, too little, or sensitivity to carbohydrates. If you have any questions about Chapter 4 or its associated materials, contact me and I'll be happy to discuss these with you.